If I can have everyone put their phones up, please, if you haven't already done so. Act like I don't. Okay, hope you guys all had a nice break. So we have 3 units that we're going to that we have left. We're going to finish everything by mid-March. Okay, and starting mid-March, we can just start going through all the. We'll start with the BC review, and then we'll incorporate all the AB topics as well. This is kind of like a miscellaneous unit. So I purposely wanted to just get through all the AP topics first semester and then all the some of the BC topics were supposed to be with previous units, but I'm going to incorporate all the BC topics or the ones that are outside of parametric and polar and series, and it just combine it all and it's called a miscellaneous unit. So a lot of this don't really have any connection with each other except for the fact that they are BC topics and that we're responsible for them on the AP exam. So we have integration by parts. We have using linear partial fractions, which is these are just additional integral rules for specific scenarios that we haven't quite seen. And evaluating improper integrals. This is where one of your bounds is either infinity or it's right in the asymptote. Right? How do you deal with those improper integrals? You have Euler's method, which is kind of like linear approximation, but it's a little bit more involved than that. You have logistic models with differential equations. This is supposed to go with the differential equation unit, but I'm going to just wait until now to go over it. And then you have arc length of curve and distance traveled. This can also be applied for polar and parametric. So we're going to see that being applied here. Really just basically taking the distance formula and applying the integral notation in front of it. We will have, so all these 6 topics. Oh, I forgot. We're also going to revisit L'Hopital's rule for these very specific indeterminate form. So these 6 or 7 topics we will start reviewing next Thursday and Friday. So no assessment before MLK weekend. So we will have 2 days of review, and then when we come back on Wednesday, we'll have another full day of review, full class period of review, and then your quiz will be the Thursday after the break. Okay. After that, we have 2 more units left. You have parametric polar and vector functions, and I think what I'm going to do is I think I'm just going to make the homework be within the packet where the notes are. So I think that will cut down on all the homework, and also I feel like that should be sufficient. So there's enough problems in the notes packet that I'm going to give you where maybe I'll just pick some of these problems out and put it into the review, but hopefully that will reduce the amount of homework, especially if I think that it's sufficient just with the ones in the packet. So I'm going to redo the calendar for Unit 9, but I'm going to keep it the same for these 6 or 7 topics. Okay, so now onto your packet here. Your calendar is on that inside cover page, and you have notes to begin with, organized in the order that we're going to do them. And then starting with page 31, you're going to have the homework pages here. So even though we're not starting with 4.4, I put them in numerical order. So your 6.6 homework will start on page 33. I will send out a link this afternoon of the unit page that we're on. I have all the keys for the notes, as well as the classwork, as well as the homework. So I'll send a link out to that, and I'll also start recording videos and putting them up for the classes that we're doing. Okay, and then so your homework will consist of homework pages as well as the AP practice problems. So AP practice problems will start on page 42. Okay. So I put all the AP practice problems near the back of your packet to hopefully make it easier to get to when I check homework. Okay, so all this I've already put it on the website. So just to let you know that you can, for every problem that you do, you should be able to check your progress with the website. Okay. Okay. Any questions with the calendar? Okay, so let's start with page 1. Okay, so integration by parts is a method of integration useful for problems involving the product of two different types of functions. So for instance, if I have logs and polynomials being multiplied together, if I have polynomial and trig functions put together, because a lot of times, if you have two different families of functions, a lot of times use substitution is not going to quite allow you to get everything cleaned up. So the giveaway with these integration rules is if you see two different families of functions being multiplied together, that's an indication that we may need to apply integration by parts. So this is I'll write this out again. The product of two different types let's see, I'm going to write these here. So logs the other, yeah, so trig and exponentials. Okay, so these are the four main ones that we're going to see with integration by parts: logs, polynomials, trig, and exponentials. And we just have to be able to know how to assign them and apply them appropriately. So integration by parts is if I have two different types of functions and I'm going to treat one as f and the other as g prime. Okay. And here's how I'm going to move forward with this. I'm going to say f times g minus the integral of f prime g. Okay, so this is a rule that we have to be able to memorize and be able to use. But just for background purposes here, integration by parts is based on the product rule. It's based on the product derivative rule. So we know that the derivative of f and g multiplied together is f prime g plus f g prime, right? We know that's one of the first rules that we learned. And if we can rearrange this, we can arrive at this integration by parts that's going to be useful for us. Okay, so let me write out those steps here that allows us to get from here to here. So the derivative of another way of saying f g prime is derivative of f times g, right? So the product rule, derivative of f times g is equal to f prime g plus f g prime. And if I rearrange this, subtracting the f prime g to the left side, I will get the derivative of f times g minus f prime g is equal to f g. Now, if I take all these terms here and put the integral in front of it, what's this going to turn into? Just, yeah, this is these two operations will wipe each other out. I'm just left with fg minus integral of f prime g is equal to integral of f g prime. So if we look at what's over here on the right side, this is basically what we're starting with. We're starting with this side here, integral of fg prime, which is equal to fg minus integral of f prime g. So really just rearranging this, putting this on the left side here. This is how we're going to start. Okay, realize I did not give a lot of space for the first example that I want to do. So here's the basic rules, is that we have to first determine what's f and what's g prime. For f, choose something that becomes simpler when you differentiate. And for g prime, choose something that can be easily integrated. I think the way that I go about doing it is just figuring out what your f is. Okay, so your f is your first priority is if you see logs in it, if you see logs in your problem, it's always going to be logs. Okay, so there's just no way around it. Your log will never be your g. So first priority is log or natural log of x. And then your second priority is if there's no logs in the expression, then you're going to pick the polynomial as your f. And that's really all the different types that you're going to see. If it's not logs or a polynomial, then your g will be the other function. It could be exponential, it could be inverse, trig, it could be you're basically, if you see logs in the problem, if there's logs paired with another function and you want to do integration by parts, logs will be your f function. Right? Polynomial, my example would be like x cubed, for instance. Anything algebraic. But if there's no logs in the expression, let's say if it was polynomial and exponential or polynomial and trig, then your polynomial will be your f function. Right. I'll see if I can squeeze this problem in. I realized I didn't put enough space above number 2 here. So here's number 1. Integral of x sine x dx. Okay, so we see that we have 2 different families of functions. You've got x and sine x. What's going to be my f? Yeah, that's my algebraic or polynomial. The other one is going to be my g. Okay, so we're going to organize it this way. We're going to say f is equal to x and then G prime is equal to the remaining expression that you see. Let me underline that entire thing here. Now, to get from, we need some more information. This is a good place to start, but we have to build a little bit more information. So on the F side, we need to find F prime. Okay. So X derivative is what? 1. Okay. Now on the G prime side, we're going to take the antiderivative. We're going to go from G prime up to G. Okay. Do you guys remember what's the integral of sine? Good, negative cosine. Yeah. Don't worry about the plus C. We'll just worry about that at the end. But I think that's the most important part here. Identifying what your F and what your G prime is, and then being able to find the corresponding information that's going to have to go into our formula. So we have F and G prime identified, right? F and G prime identified. That's the left side. And we just have to figure out how to fill out the right side. That's going to be our next step. So F times G. What's F times G going to be? X times negative cosine X. This is part of my final solution. Okay. So X times negative cosine of X minus the integral of F prime times G. What's F prime? 1. And G is, yeah, G is negative cosine. So notice that we're not going to involve G prime. We use G prime as a starting point, but really it's the G that we're after. Now this portion is going to be incomplete. We're always going to have to finish off this piece. This piece is part of our final answer, but this is still in the incomplete stage. So minus the integral of F prime times G. So this piece is done. The two negatives become positive. Let me take my next step in getting closer to my answer here. So this portion is complete. What's the integral of cosine? Sine, yep. So then our answer is negative x cosine x plus sine x. And now this is an indefinite integral. We can now include that plus c here. Okay, we'll do a lot more practice with this. Right now, I just want you guys to kind of follow along, and if the steps make sense, that's great. We'll get a lot more chance to kind of put it all together. This is new for everybody, so I don't expect you guys to be able to be proficient with this at the beginning. As long as you guys are following the steps, we're gonna get a lot more practice in. Okay. Now, for example 2, I don't want you guys to write anything down yet. Okay, just watch what I'm going to do here, and then what I want to show you is that sometimes we don't want to go through this full procedure, especially if there's a shortcut. So I want to show you why there could be a need for a shortcut. But here's the example 2 that I just want to show you visually to convince you that there sometimes can be a more effective way. Right. But just kind of watch along. This is not what we're going to put on paper, but there's also a way for us to kind of practice the steps here. But don't write anything down. Just look what I'm doing here. Okay, so we have 2 different families of functions. Again, you got x to the 4th and sine x dx. What's going to be your f function? What's your g prime going to be? No. Okay. F prime is 4x cubed. G, the antiderivative of sine is, yeah. Okay, so now my formula here is fg minus integral of f prime g. So Now, this portion is complete. This, we have to keep going. Now, look at this problem here. This is going to require another what? Another integration by parts, right? And this is tedious, right? Having to do a nested integration by parts is not going to be a fun process. So this would be 4x cubed. G prime will be cosine of x. F prime will be 12x squared. And G is going to be positive sine x. So you guys see how this is really messy, right? Every time we go through this, this is not, but probably not going to resolve itself until this gets down to a constant. So imagine having to do this, 3-4 times with nested problems within each other. This will take a long time. So there is a more efficient way of getting through nested problems, but we can only go through this specific, what we call this tab method, is if your f function can be the polynomial. If your f function is the log function, you're going to have to go through this integration by parts, but you're not going to have nested ones you got to worry about unless it's polynomial with your f function. Okay, so I want to kind of convince you that this is doable, but we have a more effective way of working through this type of problem. Okay. Now, once you learn the tab method, you can use the tab method for even example 1, but I wanted to show you the basic procedure first. Okay, so now I want to show you a way for us to get through all the mess without having to go through all those steps. So what we do is, now this is easier, but however, it's also more gimmicky in the sense that we kind of have to just know all the different things that are associated with it, but it's going to be a lot easier to go through this problem. Okay, so what you're going to do is you're going to choose the algebraic portion as your f. And then this doesn't work if there's logs involved. There's logs involved, we have to go through this original form. Tab method is not going to be effective. Okay, so what we're going to do is you're going to create two columns, an F and G prime column. So in this case, we can assign the F being the x to the fourth because there's no logs in it. So my priority for my F is always, I can always do my polynomial or algebraic. So under the F, you're going to say x to the fourth. And under G prime, you're going to say sine of x. This left side, you're going to find the derivative. The right side, you're going to take the integral. Keep taking the integral of the previous one that you see. Now, on the F side here, the nice thing about this algebraic is that we can get to a stopping point because eventually the derivative is going to turn into a what? The 0, right? So that's when we know to stop. Okay, so x to the fourth becomes next. 0. On the right side, you're going to take the antiderivative. Okay. What's the integral of sine? Negative cosine. What's the integral of negative cosine? Negative sine. Yeah, the negative stays, right? What's the integral of negative sine? Yep, the negative is going to be introduced. The two negatives cancel out. I get cosine. Cosine becomes sine. And sine becomes negative cosine. Now, we're going to be pairing up the left and the right column, but there's a very specific way you're going to pair them. You're going to pair them in terms of multiplication. You're going to pair them diagonally. So the x to the fourth is going to get multiplied with the negative cosine. The 4x cubed is going to go with the negative sine. 12x squared is with the cosine. 24x is with the sine. And 24 is with negative cosine. And then you're just going to pair all those products together. Now, there's one more thing, okay? It's the fact that there is going to be an additional sign change that's going to occur through this process. You're always going to start off with a positive term. but then everything is going to alternate after that. So negative 1 times 4x cubed times negative sine x, a positive 1 times 12x squared times cosine x, a negative 1 times 24x times sine x, and then a positive 24 times negative cosine x. I'm going to talk a little bit about why that's the case here, but for now, let's just go through this and combine all this, and that's going to be our answer. Okay, so our antiderivative of this is going to be a series of all the products of these terms. Okay. So this is what our answer will look like. Positive 1 times x to the 4th times negative cosine becomes negative x to the 4th cosine x. 4x cubed times negative 1 times negative sine becomes positive 4x cubed sine x. Positive 1 times 12x squared times positive cosine x. Negative 24x times sine x. Positive 24 times negative cosine x. And don't forget a plus c because we're dealing with an indefinite integral. Is anybody still copying this down? Okay, so the question that a lot of students have is, wait, why do we have to go through this alternating sign change? And the reason why is because if we're to go through this the long way, every time we go through a nested portion within integration by parts, what sign do you see in front? It's always that minus sign. So that minus sign with each nested is going to change the sign of the next term. So this plus minus basically allows us to keep track of all the nested minus integral of f prime g that keeps showing up. It just keeps changing the signs. So that's why we have to, and we always start with a positive, and we just make sure we alternate times negative 1 times positive 1 times negative 1 into your product of your diagonal terms. Okay, so the rest of here, we're just going to practice with this. Sometimes the G prime is going to be a little messier, especially if there's U substitution involved. But the nice thing is, once you can figure out what that U substitution pattern is, you can just keep multiplying by that coefficient over and over again. But we'll get to that. Okay, let's go to. So number 1, you see x and cosine x. These are two different families of functions. We can go integration by parts. This one, we can either do the original way, or you can go through the tab method. Okay. So just want to kind of show you that this you can do with tab method, and I think most of us will probably prefer tab method unless we're forced into the other method. But sometimes a problem is organized in a way where you have to go through, especially like a problem where something is worked out halfway. We're gonna have to go through the full method. But for this one, why don't we do the original method here, and then number 2 we can do tab method. Okay, so just so we can kind of make sure that we're can still do it. Now, what's different about? Oh wait, hold on. Okay, sorry, that we haven't gone to that yet. Okay, so let's do the original method here. Okay, so you guys try, and I'll work alongside you guys. Any questions with 1? Okay, so number 2, we can do let's do the tab method. I mean, we could do number 2 using the original method as well, but we'll just kind of alternate between the two of them, especially if they're equally, if one doesn't really have the advantage over the other. So number 2, though, we could do tab method or the original method. Though it's not a high enough degree where it's going to be not going to create a nested one here, but we can create 2 columns. First column here, 2x. We're going to keep going, keep finding the derivative until we reach 0. 2x becomes 2. 2 becomes 0. So there's not a lot that we have to worry about. Now, this one, we got to be careful here because when we take the antiderivative, there's going to be u substitution here. Now, once you see the pattern, you don't do this every time, but I want to make sure that we don't think of this as chain rule, right? This is a little bit different here. What's our u value here? Yeah. So I want to go through the full u substitution just to kind of convince you what that coefficient is going to be. So it's not going to be a times 3 that's going to show up. It's going to be a times what? 1/3, right? So it's kind of like chain rule, but it's chain rule with your leftover being the reciprocal of what you expect chain rule to be, because we're doing antiderivative, right? So cosine of u becomes sine. And I can replace that u back in terms of 3x plus 1. And then once you know that pattern, then the next antiderivative, with this being the u value again, it'll produce another what? So that will give me what? There we go, right? So once you can see what that pattern is, you can just keep applying that pattern over and over again. But just be careful. The biggest mistake students make is they think it's chain rule, so they do times 3 instead of times 1/3. But I want to just make sure that we see that it's not 3, it's 1/3. Okay, you're going to multiply the diagonals with each other. And don't forget, first term is times the positive 1. Second term is times the negative 1. And don't have to worry about that third term. That third term won't combine with anything. We're just going to multiply. So I have negative times negative, which gives me positive. I would say it'll probably be about the same. So, but I think for us, we're gonna probably gravitate towards tab method, which is fine. I just don't want us to forget how to do the original method, because sometimes we're gonna see some problems where we're forced into it, or we're forced into knowledge of it. So it's nice to be able to have that tab method for efficiency purposes. But I don't want us to forget how to do it the original way. So next one, I want us to try number 4. Let's do tab method for this as well. I mean, I think we are just gonna have an easier time with it. What's my f function here? And my g is G prime is, yeah. And then we're gonna have to go through U substitution again. But if you had to guess, what do you think the coefficient that's gonna come out of this is gonna be? Times 1/3, yeah. But if you want to go through full U substitution, convince yourself, you can do that. So, but try number 4, should look a lot like how we did number 2. The integral of e to the u is just e to the u plus c, right? After 4, we're going to try 6 and then go back to number 5. I want us to do number 6 first, because number 5 is definite integrals, and we can do the definite integral after we get comfortable with natural log. Now, on the test, you don't have to show all your U substitution steps. If you feel comfortable with what the coefficient is going to come out of the U substitution, then you can just jump to that coefficient. You don't have to show all your steps for U substitution. I just showed it to you as a way of convincing you that it's not times 3, it's times 1/3. Okay, everybody good with number 4? Okay, number 6. Number 6, it doesn't look like there's 2 expressions here. It looks like there's just natural log of x. But I can always make it natural log of x times what? Times 1, right? So I'm going to treat 1 like my quote-unquote polynomial algebraic. So there's no rule for natural log of x, but if we treat this like f and g prime, I can go through integration by parts. In this case, I'm forced into my f being natural log, right? And I can't do tab method if my f function is natural log. Okay, what's f prime? U prime over u. G prime is 1, so g is what? X. Let me write the rule up here. Okay, so we should be able to set it up here, f times g. Oops, sorry, my bad. F g prime. My bad. Stuff. Wait, this one may require another nested one. Sorry, guys. Let me come back to this one. I think let's see, minus.
Up your page, you wrote the.
Oh wait, I did it backwards. Let me see. Oh, FG prime. My bad, guys. FG prime. F prime G. Sorry about that. Okay, that's better. Okay, so the first portion is done. This comes out to be just 1. What's the integral of 1? Just x. Okay. Thanks. Okay, so now let's look at number 5 here, where we're forced into integration by parts. We can't do tab method because natural log is in the problem. But then after we find the antiderivative, we're going to have to involve the e squared and the 1 to get down to our numeric answer. Okay. I'm almost ready to. This is a quick power roll here, and once I can complete this portion, I can then involve my bounds. Oh, oops. Ease. Okay, you guys have homework. It's all in the pages are all in your packet along with AP practice. I will send out a link to the current units page so that you know where to look for as you're checking your answers and as you're working through your homework. Okay. All right, come get your phones.